Bismillahirrahmanirrahim. Assalamu Alaikum, dear students. Today we will solve new syllabus physics SSC 1, unit number 8, thermal properties of matter. In exercise 8, numerical problem 8.5 to 8.10. In previous video, we can solve 8.1 to 8.5. In this video, we can solve 8.6 to 8.10. In sixth numerical problem, an electric heater supplies heat at rate of 100 joule per second. How much time is required to rise the temperature of 200 gram of water from 20 Celsius to 90 Celsius? First of all, write the given data. Rate of heat cube delta Q by T is equal to 1000 joule per second and mass M is equal to 200 gram. Change the gram into kilogram, then 200 divided by 1000. 200 divided by 1000 is equal to 0.2 kg. Now specific heat of water C is equal to 4200 joule per kg per Kelvin. It is a constant value. And initial temperature T1 is equal to 20 Celsius. Change the 20 Celsius into Kelvin, then 20 plus 273. 20 plus 273 is equal to 293 Kelvin. And final temperature T2 is equal to 90 Celsius. So 90 plus 273 is equal to 363 Kelvin. Now change in temperature delta T is equal to final temperature minus initial temperature. So 363 minus 293 is equal to 70 Kelvin. Then we can find that time T is equal to question mark. First of all, we know the formula delta Q is equal to MC delta T. Now dividing T on both sides, so delta Q by T is equal to MC delta T divided by T. Then we can find the T, so putting the value delta Q by T is equal to 1000 joule per second. So its value is 1000. Value of mass is equal to 0.2 and value of C 4200 multiplied by delta T 70 Kelvin divided by the time. Now we have T is multiplying on the other side and 1000 is dividing on other side. So 0.2 multiplied by 4200 multiplied by 70 divided by 1000. The answer will be 58.08 seconds. In numerical problem 7, how much ice will melt by 50,000 joule of heat? Latent heat of fusion of ice is 33,600 joule per kg. Now, first of all, write the given data amount of heat. Delta QF is equal to 50,000 joule and latent heat of fusion HF is equal to 33,600 joule per kg. Now we can find the mass of ice M is equal to question mark. Now we can write the formula latent heat of fusion delta QF is equal to M multiplied by HF latent heat of fusion. Here we can find the value of M, then latent heat of fusion divided on other side. So M is equal to amount of heat delta QF divided by latent heat of UNHF. Now for solution, putting the values. M is equal to 50,000 divided by 336,000 is equal to 0.149 kg. Now we convert into gram, then multiply by 1000. So M is equal to 0.149 multiplied by 1000 is equal to 149 grams. In question number 8, given statement is find the quantity of heat needed to melt of 100 gram of ice at minus 10 Celsius into water to 10 Celsius. First of all, given note are given. In some numerical statement, these constant values are given and some way these values are not given. So you know that specific heat of ice is 2100 joule per kg per Kelvin and specific heat of water 4200 joule per kg per Kelvin and latent heat of fuel of ice is equal to 336,000 joule per kg per. Now write the given data. Mass of ice M is equal to 100 joule. First of all, 100 gram change into kilogram, then 100 divided by 1000 is equal to 0.1 kg. Now, initial temperature T1 is equal to 10 minus 10 Celsius. Minus 10 Celsius change into Kelvin, then minus 10 plus 273 is equal to minus 263 Kelvin. Final temperature T2 is equal to 10 Celsius. 10 Celsius change into Kelvin, then 10 plus 273 is equal to 283 Kelvin. Now, specific heat of ice C1 is equal to 2100 joule per kg per Kelvin and specific heat of water denoted by C2 is equal to 4200 joule per kg per Kelvin. Now the latent heat of fuel of ice is equal to HF is equal to 336,000 joule per kg per Kelvin. Now we can find that delta Q quantity of heat. So for a quantity of heat, we can find the values of other quantities. Here we use the formula delta Q quantity of heat is equal to delta Q1 plus delta Q2 plus delta Q3. Here we can find 3 times of quantity of heat, then sum is given that the total heat. So in solution, in first part, amount of heat supplied to ice increase the temperature of minus 10 Celsius to 0 Celsius. So it is denoted by delta Q1. Then initial temperature T1 is equal to minus 10 Celsius is equal to minus 10 plus 273 is equal to 263 Kelvin and final temperature is T2 is equal to 0 Celsius, so is equal to 0 plus 273 is equal to 273 Kelvin and change in temperature. Change in temperature delta T is equal to 273 plus 2 minus 263 is equal to 10 Kelvin. Now we have delta Q1 is equal to MC1 delta T is equal to 0.1 multiplied by 2100 multiplied by 10 is equal to 2100 joule. Now for part 2, then we have amount of heat supplied to the ice at 0 Celsius convert into water. Now delta Q is equal to MHF, mass multiplied by latent heat of fuel. So 0.1 multiplied by 336,000 is equal to 33,600 joule. In part 3, we can find that amount of heat supplied to the water increase the temperature 0 Celsius to 10 Celsius. Then we have initial temperature T2 is equal to 0 Celsius is equal to 273 Kelvin and final temperature T3 is equal to 10 Celsius is equal to 283. Now we have change in temperature in equal to 10 Kelvin. So we can find that delta Q is equal to M C to delta T. Then 0.1 multiplied by 4200 multiplied by 10 is equal to 4200 joule. Now the final result, so the total heat supplied at minus 10 Celsius to 0 Celsius is equal to delta Q is equal to delta Q1 plus delta Q2 plus delta Q3. So 2100 plus 33,600 plus 4200 is equal to 39,900 joule. In question number 9, how much heat is required to change 100 gram of water to 100 Celsius into steam? First of all, write the given data. We have mass of water M is equal to 100 gram. Change 100 gram into kilogram, then 100 divided by 1000 is equal to 0.1 kg. And latent heat of vaporization HV is equal to 2.26 multiplied by 10 raised to power 6 joule per kg per Kelvin. To find amount of heat, so delta QV is equal to question mark. Now using the formula latent heat of vaporization, then delta QV is equal to M multiplied by HV. So putting the values, delta QV is equal to M multiplied by HV is equal to 0.1 multiplied by 2.26 multiplied by 10 raised to power 6. Then it will be equal to 0.226 multiplied by 10 raised to power 6. Now write in scientific notation, then delta QV is equal to 2.26 multiplied by 10 raised to power 5 joule. Now in last numerical, this numerical value is so short, but numerical problem is so long and but confusing numerical. So first of all, taking the three parts. So you can read the statement carefully and find the value. Find the temperature of water after passing 5 gram of steam to 100 Celsius through a 500 gram of water at 10 Celsius. First of all, write the given data according to the statement. So we have write that mass of steam M1 is equal to 5 gram. Now 5 divided by 1000 is equal to 0.005 kg and temperature of steam T1 is equal to 100 Celsius, that is equal to 100 plus 273 is equal to 373 Kelvin and mass of water M2 is equal to 500 gram. Then we have 500 divided by 1000 is equal to 0.5 kg and temperature of water T2 is equal to 10 Celsius. Then 10 plus 273 is equal to 283 Kelvin. Now, so specific heat of water C is equal to 4200 joule per kg per Kelvin. Now, latent heat of vaporization of water HV is equal to 2.26 multiplied by 10 raised to power 6 joule per kg per Kelvin, and it is a constant value. Now we can find that the temperature of water after passing the steam, that is mean that we can find that T3. So we can write the formula: heat lost by a steam is equal to heat gained by a water is equal to delta Q1 plus delta Q2 is equal to delta Q3. Now we can see that in solution delta Q1 is equal to delta Q1 plus delta Q2 is equal to delta Q3. First of all, we can understand that what is Q1, Q2 and Q3. So we know that in first part, latent heat lost by a steam is equal to delta Q1, that is equal to M1 HV, and in part 2, heat lost by a steam to attain the final temperature, that is equal to delta Q2 is equal to M1 C delta T, and part 3, heat gained by a water, that is equal to delta Q3 is equal to M2 C delta 3. Now we have finding the values, then putting the value M1 is equal to delta Q1 is equal to M1 HV is equal to 11,300 plus delta Q2 is equal to 21 multiplied by 373 minus T3 is equal to M2 2100 multiplied by T3 minus 283. Now we can find the value of T3. Then we have multiplying each term. Final answer is 11,300 plus 7,833 minus 21 T3 is equal to 2100 T3 minus 594300. Now we have adding the values 11,300 plus 7,833 plus 594300 is equal to 2100 T3 plus 21 T3. So the answer is 61,433 is equal to 2121 T3. This value is divided on other side, then T3 is equal to 613433 divided by 2121. This answer is equal to 289.2 Kelvin. Now change into Celsius, then 289.2 minus 273 is equal to 16.2 Celsius. So the final answer of T3 is equal to 16.2 Celsius. Best of luck in next video with next lesson. Take care.